Hi there, scientists! I am quite curious about this matter I found. Wherever I go, they are all around. They come in different shapes and create no sound.
Some look sharp and some are round. What are they? And why do they exist on the ground?
Okay. Hang on there. Hi, scientists! It's me, Teacher Paul Guanzon, your adventure partner. It's nice to be back together with you. I know that you're all excited today because we will be learning and having fun again together. Come and join me as we blast off the rocket ship of new learning. Where is my magnifying glass? Oh, here it is! Let's go and let's eye Earth. Imagine Earth.
Our lesson is for you to master the nature of Earth and life science intended for grade 11 senior high school. Today, we will be exploring the minerals and rocks. Here are our objectives. As we go navigate the lessons, you are expected to: Number 1, identify common rock-forming minerals using their physical and chemical properties. Number 2, classify rocks into igneous, sedimentary, and metamorphic. Number 3, identify the mineral's importance to society. And number 4, describe how our minerals are found, mined, and processed for human use.
Before we proceed, here are our reminders. Check your prior knowledge of the lesson from your junior high school science subject. Listen and pay attention to the details. And bring with you your paper and pen for jotting down important concepts of our lessons. The interactions between the Earth's subsystems are complex and dynamic. Though their effects are not always obvious, there are some extremely dramatic changes that are also slow or nearly undetectable changes. This is how our Earth's biosphere, hydrosphere, atmosphere, and geosphere work, and we, the living organisms, depend on it. But what if we imagine Earth having no solid surface that we can stand on? No mountains, no hills, or no continents to live on? Imagine Earth.
Every day, we encounter different things or materials found in our surroundings. We see buildings, busy streets, cars, cell phones, pencil, and even this magnifying glass. But we tend to disregard this matter found beneath our feet.
These matter are called rocks.
They are among of the first tools and weapons used by humans. They used rocks in making fire to tame animals, cook their food, and to make them warm. Later, metals became the basis of wealth and the foundation of empires. Ancient history is recorded on tablet of clay and illustrated with mineral pigments. Rocks and minerals are totally linked to the rise of mankind and civilization. The strength and power of early nations often stemmed from the mining activities and the amount of such metals as gold and silver in the treasury. Likeness of significant people have been preserved in stone and metal monuments and in coins made of precious metals. Minerals have also played a significant role in exploration of the world, colonization of foreign lands, and the trade, commerce, and industrialization of civilized societies. Modern society depend on rock and mineral resources. They are essential for the construction of our cities and for power, transport, and communications. They enrich arts, and we wear them as personal adornments. The Earth is mostly made of rocks. We learned from our previous episode that the geosphere is the solid part of the Earth, And that includes the small and boulders of rocks. You might be asking what they are made of, where do they come from, or how do they form?
To understand this, we need to learn first the field of science that studies the solid matter that makes up Earth. It is called geology. This science is concerned with the changes of the Earth over time. It deals with the Earth's physical structure and substance, its history, and the processes that act on it.
Geologist is a scientist who studies the history of the planet we live on. They study Earth processes, investigate Earth materials, like minerals, including the methods to extract this.
It is amazing that our planet produces a dazzling variety of inorganic chemical compounds. They are called minerals, the building blocks of rocks.
Examples are talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. These are the 10 minerals of distinctly different hardness identified by Friedrich Moos. These minerals are only few of more than 4,000 naturally occurring minerals identified in our planet. Each year, about 60 to 80 minerals are discovered. With this number, how can we determine whether a material is classified as mineral or not? The word mineral may mean differently to different people. Some may associate it with gemstones, rocks, and geology, or even vitamin pills.
To a geologist, however, a mineral must have all of the following characteristics.
First, minerals are naturally occurring. It means that it cannot be man-made, manufactured, or created in laboratory. It is a product of Earth's natural processes. The steel that we mostly use for making buildings and tools is not a mineral because it is an alloy produced by people. Second, minerals are chemically inorganic. This means that the material's chemical composition is without carbon. It must be a product of Earth's physical processes. Pearls and woods are from the clams and trees, and thus these are not minerals. The third one is minerals are homogeneous solids. It has a definite volume and rigid shape. It is chemically and physically uniform down to the atomic level. Fourth, minerals have definite chemical composition. This means that all occurrences of that mineral have a chemical composition that varies within a specific limited range. Example of this is the mineral called halite, or also known as rock salt. It has a chemical composition of NaCl. It is made up of equal number of atoms of sodium and chlorine. Lastly, ordered internal structure or crystal structure. The atoms in a mineral are arranged in a systematic and repeating pattern. Liquids like water and mercury and the gases like air do not have a crystalline structure and are therefore not minerals.
And those are the 5 characteristics of a substance in order to be considered as a mineral. Now, if you found an unknown mineral, how are you going to identify it using your 5 senses? This time, let's take a look at these different minerals. Each of these minerals has a unique set of properties. These include color, streak, hardness, cleavage, crystalline structure, diaphanity, luster, tenacity. Using our samples, we will be identifying the properties exhibited. Let's explore it one by one. Most of the minerals have a distinctive color that can be used for identification. If minerals are either clear or white, They are absolutely pure. They are rare in nature. Yet, many minerals are colored by chemical impurities. Color alone is not reliable as a single identifying property.
For example, pure quartz is colorless, whereas amethyst, a purple variety of quartz, has its purple color caused by traces of the element iron. The amount of iron present determines the intensity of the color.
The streak of a mineral is the color it displays in finely powdered form when a mineral is rubbed on a square porcelain known as a streak plate. This method is being used in pawn shops in order to determine if a gold jewelry is real or not. Real gold also leaves a gold streak when scratched against a small bit of a streak plate. Non-metallic minerals have either a white streak or a very light colored streak.
Hardness is one of the better properties of minerals to use for identifying a mineral. Hardness is measure of a mineral's resistance to scratching. The most scale is a set of 10 minerals whose hardness is known.
Friedrich Moos, a German mineralogist, developed the scale in 1812. He selected 10 minerals of distinctly different hardness that ranged from a very soft mineral to a very hard mineral. The softest mineral, talc, has a Mohs scale rating of 1. Diamond is the hardest mineral and has a rating of 10. Softer minerals can be scratched by harder minerals because the force that hold the crystal together are weaker and can be broken by the harder mineral. Minerals tend to break along lines or smooth surfaces when hit sharply. Different minerals break in different ways, showing different types of cleavage. The other one is crystalline structure or habit. Mineral crystals occur in various shapes and sizes. The particular shape is determined by the arrangement of the atoms, molecules, or ions that make up the crystal and how they are joined. This is called the crystal lattice. There are degrees of crystalline structure in which the fibers of the crystal become increasingly difficult or impassable to see with our naked eye or even with the use of a hand lens.
Diaphanity or transparency is mineral's degree of transparency or ability to light to pass through it.
The degree of transparency may also depend on the thickness of the mineral. To test for transparency, hold the specimen up to the light. If you can see through it, it is called transparent. If you put your finger behind the mineral and see the shadow of your finger, it is called translucent. If no light comes through it, it is called opaque.
Luster is the property of minerals that indicates how much the surface of a mineral reflects light. The luster of mineral is affected by the brilliance of light used to observe the mineral surface.
Tenacity is the characteristic that describes how the particles of a mineral hold together or resist separation. Examples are brittleness, malleability, ductility, flexible but inelastic, flexible and elastic, and sectility.
Upon knowing the different characteristics and properties of minerals, I bet you know already the different uses of minerals around us.
Now, let me show you a table that will help you organize your thoughts, and I will be sharing with you my sample answer. On the first column is the specific mineral. Write down your identified mineral. Then, on the second column is on the uses. Here, you will write a specific use or uses of the minerals.
You may answer this activity after the episode. Let your parents, guardians, or your siblings assess your answers.
This time, I will be showing you my answers. Halite, mineral found in table salt, used as preservatives. The mineral talc is a main component for making face and foot powder. It has ability to absorb moisture, oils, and odor. The next mineral is diamond. It consists of pure carbon. It is used as gemstones for making jewelry. The last one is the mineral quartz. It is used in concrete, glass, scientific instruments, and watches. It is also used to make silicon semiconductors. Now it's your turn.
That is cool, right? I bet you learn a lot about minerals. Minerals are the building blocks of our dynamic planet. This material is all around us. The use of minerals includes building materials, cosmetics, cars, roads, and appliances. Also, to maintain a healthy lifestyle and strengthen the body, we need to consume minerals daily. Remember that minerals are the building blocks of rocks. Speaking of rocks, what are rocks?
These are the common material and core foundation of Earth. If we dig down to the crust, different layers of this matter lay below. They are observable in every portion of our surrounding and exist from land to ocean.
Take a look at these boulders of rocks. They come in different forms, shapes, and colors. And if we look all around us, rocks exist in nature. They seem to grow and multiply, but they are not. Do you think rocks can reproduce? Or is it unlimited? To answer those questions, let me take you to an adventure. Let's journey to the world of rocks.
Located under the Earth's surface are extremely hot liquid and semi-liquid material, a molten rock, and it is called magma. Its temperature ranges between 700 degrees Celsius and 1,300 degrees Celsius. Magma leaves the confines of the mantle and crust through the volcanic eruption. These magma solidifies to form a certain type of rock, the igneous rock. The rocks forms
From the cooling and hardening of molten magma in many different environments. The chemical composition of the magma and the rate of which it cools
determine
what rock forms. Igneous rocks can cool slowly beneath the surface or rapidly at the surface. These rocks are identified by their composition and texture. More than 700 different types of igneous rocks are known. There are two types of igneous rocks. When they are formed inside the earth, they are called intrusive or plutonic igneous rocks.
Diorite and granite are examples of common intrusive rocks. If you look at the texture of these rocks, it is coarse and with large mineral grains. It indicates thousands or millions of years cooling down inside the earth, a time course that allowed large mineral crystals to grow.
The second type of igneous rock is when it forms outside or on top of the Earth's crust. They are called extrusive or volcanic igneous rocks.
Extrusive igneous rocks can also have vesicular or holy texture. This happens when the ejected magma still has gases inside of it, so when it cools, the gas bubbles are trapped and end up giving the rock a bubbly texture. An example of this would be pumice. Rocks may also change into a new type of rock. This is referred to as metamorphic rock.
In order to form a metamorphic rock, it requires a very specific condition. It must be exposed to high heat, high pressure, or to a hot mineral-rich fluid below the surface. The constant exposure of rocks to these extreme conditions makes it not to melt. the rock becomes metamorphosed.
Metamorphism may change the mineral's composition and the texture of the rocks. For that reason, metamorphic rock may have a new mineral composition and/or a texture. There are two basic types of metamorphic rocks. The first is foliated metamorphic rocks. It is banded or layered texture due to its exposure to high temperature and pressure. Examples are gneiss, phyllite, and slate. The second one is the non-foliated metamorphic rocks. These rocks are characterized by the absence of banding or layering and can be observed to have small or large grain-sized minerals. Marble and quartzite are examples of which.
In contrast to igneous rocks and metamorphic rocks, which are formed deep within the earth, these types of rocks are formed on or near the Earth's surface. This is sedimentary rock.
There are several geological processes that lead to the creation of these type of rock, such as erosion, weathering, dissolution, precipitation, and lithification.
Erosion refers to the movement of rocks, debris, and other products of weathering from one location to another. When large rocks are broken into smaller pieces in weathering, erosional geomorphic agents would then carry these small fragments.
The wind and rain during erosion and weathering will break down the large rocks into smaller ones. This may also transform boulders of rocks and even mountains into sediments.
A chemical weathering called dissolution makes water slightly acidic, which slowly wears away rocks.
And that also makes some monuments to weather. Finally, lithification is the process by which clay, sand, and other sediments on the bottom of the ocean or other bodies of water are slowly compacted into rocks from the weight of an overlying sediments. There are three types of sedimentary rocks. One is clastic sedimentary rock, which is formed from the accumulation of clast like little pieces of broken rocks and shells. Examples are sandstone and shale. Second is the chemical sedimentary rock, which formed when dissolved minerals precipitate from a solution. Example is halite that form when a body of seawater becomes closed off and evaporates.
The third one is the organic. It formed from the accumulation of animal debris. Example is coal. This is composed of organic matter in the form of plants' fragments. A useful way to illustrate how the three main types of rocks are related to one another and how changes to rocks happen in a recurring sequence is a rock cycle. It can be presented in a diagram like this one. The rock cycle is a web of processes that outlines how each of these three major rock types, igneous, metamorphic, and sedimentary, form and break down based on the different applications of heat and pressure over time. The processes that change one rock to another are crystallization, metamorphism, erosion, and sedimentation. Any rock can transform into any other rock by passing through one or more of these processes. This creates the rock cycle.
This matter found just right below our feet seems to be useless and may not affect our day-to-day life. But we are wrong because rocks are as important now as they have ever been. Rocks are used in making cement, for roofing materials, and building infrastructures, bridges, and roads. In schools, they are used in writing on chalkboards,
making statue, ornaments, and decorations.
For bathing, we sometimes use a bath scrub like the pumice, diamond, sapphire, and others are used as jewels. Some rocks act as tourist attraction sites and for recreations. These are only a few of the uses of the different rocks. That is what makes Earth a special and habitable planet. We did a good job, grade 11. Indeed, you are all scientists. Do you want more about our planet? More features and fun-filled experience on the planet that harbors life. I am your adventure partner, Teacher Paul Gonzon, saying, imagine Earth on what we will explore tomorrow. I, Earth. Imagine Earth.